Hi everyone, Notes 3.1 are on interpreting scatter plots. And before we do any type of interpreting, we have to define different types of variables. So a variable is something that changes, right? So our first variable that we want to define is called an independent variable. And an independent variable is literally what it says. It's independent. It's a variable that stands alone. It isn't changed by other variables, okay? And then the dependent variable is a variable that is based on another variable. And something that might help you remember this is the independent variable is pretty much the cause. You can think of it like the cause, and the dependent variable is kind of like the effect, right? So like, let's say, for example, we talk about your distance and gas consumption, okay? The distance is the independent variable because that's the standalone. You're just going to drive, right? It's the cause. And then the effect is what happens to your gas consumption. Your gas consumption increases because you drive really far. So that means your gas consumption is the dependent variable. It depends on how far you drive. Does that make sense? Hopefully. If not, drop me an email so I can help you out with that. And then one quick note too is that the independent variable is always going to be your x variable. I can't stress this enough. And then your dependent variable is always going to be your y variable. So that's going to help us out when we create our scatter plots, okay? So for example, think about two variables. Our two variables could be time spent studying and your test mark. So I want you to ask yourself right here, does the test mark depend on your time spent studying, or does the time spent studying depend on your test mark? And hopefully you will say the first is true, that the test mark depends on the time spent studying, which means that the test mark is the dependent variable, which means that the time spent studying is the independent variable. Okay, so again, the test mark is dependent because it depends on how long you spend studying. And because the test mark is the dependent variable, then the time spent studying has to be the independent variable, which is your cause, right? Your time spent studying will cause you to get either a good mark or a bad mark. Your mark is the effect of the time spent studying. Okay, now there are several different types of relationships that can exist between the two variables we're talking about, your independent and your dependent variables. And three of them include either a positive correlation, a negative correlation, or no correlation. Now, a positive correlation will happen when the independent and dependent variables move in the same direction. And what I mean by that is if the independent variable increases, then the dependent variable will increase. If the independent variable decreases, then the dependent variable would decrease. So let me show you what this would look like right here. And just a reminder, your independent variable is always on your x-axis, and then your dependent variable is always on your y-axis. And essentially what this is saying is as the independent variable is going up, your dependent variable is going up. So if you can see here, this has a positive trend upwards, okay? As the independent variable is decreasing, your dependent variable would also decrease. So we can also look at it like this as well. Either way, it's still looking like a positive graph. And one important note is that the look of this will be from left to right, our graph will go up. So if you look here, from left to right, our graph is increasing. Okay. All right. Now, a negative correlation is going to be the opposite. Instead of when the independent and dependent variables move in the same direction, now they're going to move in opposite directions. So positive is same, negative is opposite direction. So essentially what this is saying is as the independent variable increases, the dependent variable will decrease. Or vice versa, as the independent variable decreases, the dependent variable will increase. So if you look here, our graph will look as follows. So this time, as we are increasing our independent variable, as we increase our x values, our y values are going down. So this time the trend is going down. Okay, this has a negative trend. Or vice versa, if your independent variable is decreasing, then your dependent variable will increase. So notice here, as our independent variable goes down, our dependent variable goes up. So it still looks exactly the same, okay? Now, how does it look? Same thing, from left to right, instead of going up, it will go down. Okay, and then the last type of situation we're going to look at is a situation where there's no correlation. And this happens when the independent and the dependent variables have no relation. So again, we're going to put independent on the x-axis, we'll put dependent on the y-axis, and it's not generally going up like it is here. It's not generally going down like it is here. It's just super random. Okay, so if you can see here, there's really nothing happening. There's no relationship between the independent and the dependent variables. Okay, so let's take a look at what we have here. For each of the scatter plots below, state what type of relationship there is between the variables and explain why you think so. Use the words positive, negative, or no correlation and state the independent and dependent variables. So here, in our first example that we will look at here, the height and age of students, let's first of all determine what's independent and what's dependent. So our independent variables will always go on the x-axis. So we can say that our independent variable is the age in years. And we can say that our dependent variable is the height in centimeters. Okay, and not just because it shows it to us in the graph as the age being on the x-axis and the height being on the y-axis, because that's always going to be true, but also because the height depends on how old you are, right? You're most likely not going to see a 2-year-old walking around who's 6 feet tall. More likely than not, you were taller at 10 years of age than you were when you were 3 years old, right? So we can say that typically the height will depend on age. Now I want to know, is there positive, negative, or no correlation? Well, clearly the correlation is positive. How do we know? Because our graph is increasing. It's going up from left to right, but also because the older you are, the taller you're going to be. So we can say that this has a positive correlation. Okay, in our next example, we're looking at height and time to travel to school for high school students, right? So our independent variable right here would be the height in centimeters. How do I know that? Because this is the x value. And then we know that our dependent variable is the time in minutes. And again, how do we know that? Because this is our label on our y-axis right here. But here's the thing, our graph is super random. Like, it's not going up, it's not going down, it's just super random. So here we can say that there is no correlation, which by the way should make sense because a person's height has nothing to do with how long it takes them to go to their high school, right? So there's no correlation. So that's why finding independent and dependent in something like this where there's no correlation is a little bit trickier, but luckily we have our x and y axes to help us out here. Okay, all right, in our last example, we're going to look at water temperature and depth in a lake. Okay, so here we know that our independent variable is going to be the depth in meters. And here we know that our dependent variable is going to be the temperature in degrees Celsius. And as we look here, it appears that it's decreasing as you go from left to right. It's going down, which means that this has a negative correlation. And that should make sense because the deeper you go, the colder the water is going to get, okay? And that's another reason why we know that our independent variable is our depth and our dependent variable is the temperature, because the temperature depends on how deep down you are in that lake. All right, so now let's talk about how to graph out some scatter plots. So here it says the table below shows the average and maximum longevity of various animals in captivity. And just to note, longevity just means how long the animals will live, okay? So draw a scatter plot and determine what type of relationship, if any, exists in the data. So here, this is nice because it labeled it for us. It labeled the independent variable as average and then the dependent variable as the maximum. And so let's go ahead and do our graphs, okay? So our first point that we see here is 1247. So this is saying that if on average an animal lives for 12 years, the maximum age that that animal of that species has lived is 47. So I'd go to 12 on the x-axis for average, and then I would go all all the way up to approximately 47 on the y-axis, and I would plot my point there. So I would go, so my point would be right here at 1247. Okay. For my next point, I would go to 25 for average and then up to 50 for my max. For the next point, I would go to 15 on average and then up to 40 for my max. 8 for average, 20 for max, 35 for average, 70 for max. And you don't have to draw these lines. I'm just drawing them to show you how I'm placing these points. 40 for average, 77 for max. 41 for average, 61 for max. And then 20 for average, 54 for max. And then we want to determine what type of relationship, if any, exists in the data. And it appears to be here that we have a positive correlation. So here we can say, how do we know it's positive? Because it's going up from left to right. And also as the average years increase, the maximum years increase. Okay, they're moving in the same direction. So what does it mean specifically in this problem? We have to expand on the fact that we say that there's a positive correlation. We will say as average longevity increases, maximum longevity will increase. And that's how we do this type of a question here. So we can draw scatter plots by hand. We can also use technology to draw scatter plots. So that's what we're going to do in our last example. So we're told the local ice cream shop keeps track of how much ice cream they sell versus the afternoon temperature on that day. Here are their figures for the last 12 days. Plot this data using Desmos. So first of all, the first thing we need to do is go to desmos.com, but this time don't go to scientific, just go to regular Desmos, and we're going to actually use the graphing calculator. And because we have a table of values, we're going to add item here, okay? And you might want to take notes on how to do this because you're going to be asked to do it in future assignments, okay? And then we're going to go to add a table, okay? And here, the x-axis or the independent variable is going to go in the first column and the dependent variable is going to go in the second column. So let's take a look at what's given to us. So it says here that the temperature is written right here and then the ice cream sales is written right here. And your ice cream sales are most likely going to be based on the temperature, right? More likely than not, you have more people buying temperature in hot weather than you do in cold weather, okay? So here, my X values, this 14.2, 16.4, 11.9, all of these values are gonna go in for my X values in Desmos. So I'm literally just going to type in these values, 14.2, 16.4, 11.9, so on and so forth. So these are the temperatures. Then in the corresponding Y values, we're going to fill in these ice cream sales that we have here. So we're going to fill in that 215, 325, and the 14.2 degrees corresponds with $215 worth of ice cream. The 16.4 degrees corresponds with the $325 worth of ice cream. Okay, so let's keep going. Okay, and we are done with our note here. So let's go ahead and use just Desmos to see what we need to do now. So if you notice, none of the points are showing up, and that's because all of my X values, my lowest X value is 11.9, and my highest X value that I'm looking at here from a quick scan, I believe is 25.1. But if you notice here, it only goes out to 10. So this isn't going to work for us. So what we do is we click on this wrench button, this graph settings button in the top right hand corner right here. And we change our X values. And since we know that our lowest X value that we're looking at here is 11.9, I'm going to go a little bit lower than that. I'm going to start at 10. Okay, and then I know that my largest X value here that we're looking at is this 25.1. I'm going to go a little bit above that. I'm going to use nice, easy numbers, and I'm going to go to like 30. Okay, but I need to add a label for my X axis, and the label is we're talking about degrees, we're talking about temperature in degrees Celsius. So I literally will just type that in. Okay, and then for my y-axis, if you look at these values that we have here, I still can't see any of my points because my y values are in the hundreds. They're too large. So from a quick scan, it appears that 185 is the lowest number that we have here. And I may be wrong about this, but I believe that the highest number that we have here is 614. So again, I'm going to go to this wrench in the top right-hand corner. And I'm going to go a little bit below that 185, that minimum point that we have here. And I'll start it at maybe like 150. Okay. And then my highest number that I have here is 614. So I'll go to maybe like 650. Okay. Oh, there we go. Now we can see our graph right here. And I'm going to label my y-axis as ice cream sales. And the ice cream sales are in dollars. Okay. And then you can actually zoom in if you want, zoom out, whatever you need to do to see it better. But this is our scatter plot, and that's how you do it using Desmos. Okay. And that's it for this video. If you have any questions, let me know. Otherwise, I will see you in class. Bye.